GM. Hi, everyone. So nice to see so many of you guys join today. Today we have a super exciting workshop. We're all going to get an introduction to Shardeum from two amazing speakers who are just joining me now. Hi, Chris. How are you?
Hi, Clara. Things are good. Exciting for today.
Same. I'm super excited, and I'm sure everyone else is as well. Please feel free to use the chat, say hi to each other, let us know like where you are in the world, all that kind of fun stuff. We have another one of your colleagues just joining us now, so we're going to wait for him. And there he is now. Hi,
Yeah, hi.
How are you?
Doing good.
Good. I don't have much information to say. I just want to say welcome, everyone. So nice to see you. Obviously, loads of you, I'm sure, have registered to the Web3 or Scaling Web3 Hackathon as well, where we're being joined by Shardeum. So feel free to pop any questions that you have about that, maybe about the bounty, that sort of fun stuff, as well in the questions tab. So right now we're using the chat tab. If you go a little bit to the left, you can see the questions tab. Feel free to pop any questions you have there, and I'm sure our lovely speakers would be more than happy to give you guys an answer. That's it from me. I'm going to hand over now to you guys. So enjoy, everyone.
Thank you, Clara. So welcome to the Shardeum workshop. I will do a very quick introduction once Sandipan pulls up the slides. And I'll give you a bit of an idea of why we've created Shardeum and what it's all about. And then Sandipan, my colleague, is going to walk you through a demo and show you how to build dApps on the Shardeum network. So with that out of the way, let's go to the next slide. I wanted to start with a story from back when I was much younger and I had much more hair than I have now, the beginning of the World Wide Web. And what we're looking at right here is the Mosaic web browser, which came out in 1998. So we're talking ancient history here. And the interesting thing to me was that when this just came out, the internet was much smaller and more naive. And you could tell because this web browser didn't just come with the ability to open web pages, but you could edit them as well. Everything in the beginning of the internet was made for participation. It was an invitation not just to read stuff, but to produce and participate as well. Let's go to the next slide. And this is one of my favorite images that you can see on the left here. I love cats myself. I have two of them. So that's one of the reasons. The other reason is that this is seen as probably the first ever meme. Icon has cheeseburger. And it was a photo of a fun cat with a fun expression, which is hilarious. But before that moment, most of the stuff that was shared, most of the graphics came out of professional studios. Pixar, Disney, Marvel. It was not something where people could participate because those early roots of the internet where everyone could create content were long gone because it became commercial, became a large place, and it became a place that could be abused as well. So for almost a decade from the beginning of the internet up to that moment, the internet had become a place where a few large players dominated the world and they would decide what you could create, what you could see, and participation wasn't a thing until memes came along. Because the wonderful thing about that image with a cat is that it doesn't just say, hey, that's a funny photo. It also comes with the message of, if you have a funny photo and you know how to put some text on it, you too can create memes. Now, obviously, everyone here has seen memes. And if you look at TikTok, that's a clear continuation of the same message. There's certain dances for certain songs or joke formats or sketches based on musical or theater performances. And it's someone creates something interesting and everyone is invited to play along, do their own version and improve on it. Let's go to the next slide. As I mentioned, as the internet became larger, more commercial, participation was limited. We got some of that back through TikTok and memes and everything else. That wasn't true everywhere. And some of the places where that wasn't true was who is allowed to do business, where are you allowed to do business, and are you able to participate in the foundations of the internet? And for a very long time, the answer to that was no. Unless you play by the rules by the big providers, you were not a participant, you were not large enough, you were not powerful enough, and you had to live by someone else's rules. So Web3 is the promise of bringing the ability to do business, to transact, to innovate to everyone. But of course, to be able to make that happen, there's a couple of challenges. We all know that in Ethereum and Bitcoin, transactions can sometimes take minutes. No one's going to wait minutes when you just want to buy something small, right? Scalability is relatively low. If everyone actually started using those networks, the price per transaction would shoot up, the performance would become a massive bottleneck. So in a way, success would actually be very detrimental to using those kind of platforms. So we have been working on a completely new solution, which we call dynamic state sharding. And dynamic state sharding means that we're spreading out all the transactions over a large network of participants that run Shardeum nodes, or validators as we call them. So this network uses the EVM, the Ethereum virtual machine. So you can use it with all the dApps and smart contracts that you're already familiar with, written in Solidity. Existing apps can easily support this network as well. And because we build it for scalability and easy participation, the transaction fees are incredibly low as well, below 1 cent. So between making it fast and cheap and open to participation, our goal is to open this up to everyone. Let's go to the next slide. So the way that this works is that there can be thousands of nodes or validators. They validate transactions when you execute a Solidity contract. And we select a number of those to participate actively in processing contracts. And we select which nodes do this based on the Ethereum addresses that are active in that transaction. So there could be a node that's responsible for a certain amount of addresses. There's another node that is the counterpart to that, that's responsible for the address of the person you're transacting with. And those two will connect to each other. Now, obviously, those nodes can do a few transactions per second already, but because everything is spread out over such a large network, every transaction will use different nodes, giving you incredible performance out of it. Next slide. And this is kind of visualization of how that works in practice. So the green plus blue is the total amount of validators that are running on the network. Anytime that we see that the transaction volume goes up, there's some automated scripting that happens that says, how busy are my nodes at the moment trying to deal with this traffic? And if they see that the traffic is higher than the current capability can deal with, it takes a number of nodes out of the standby pool and adds that to the total network, as you can see in the right with the blue dots. The total active number of nodes that the data and the traffic is sharded between increases. So the capacity for how many transactions you can do scales up with the usage of the network. And this scaling could happen nearly infinitively. When I say nearly, there's always 32-bit integers that add some limitations on how many nodes you can add to it, but it's large enough that in practice you will never actually see these limits. And that makes it useful not just in very large transactions that we've seen in the past, where when a transaction fee is $50 and the transaction time is 2 minutes, you just want to use it for things that cost thousands of dollars, right? You definitely don't want to use it for selling a little fun thing to use in a game or buying something locally from a store. So by making this fast and scalable, we're making utility available to real world applications in places where it wasn't before. Next slide. Finally, and this is something where, as the head of open source, I obviously care a lot about, but one of the ways in which participation was not possible before was in the source code of what makes the network. If you look at something like Bitcoin, for instance, the OG of decentralization, the amount of core contributors who can change the Bitcoin code is only like 12 people. 12 people is not a lot. That is actually incredibly centralized and cliquish. So one of our big goals is to make sure that we don't just build a scalable, high-performance, secure, and affordable network, but our North Star is to make sure that at some point we get to the place where 51% of more of the people who contribute and maintain the code of Shardeum come from the community and not from the initial group that has built this all. We're launching that pretty soon. Right now we're on Testnet. Next slide. I was waiting for Sandipan to the next slide. Thank you so much for controlling this, dude. So right now we're in Testnet, and that is incredibly popular. We've had over 1 million people show interest and create accounts, 600,000 members on Discord at the moment, which is overwhelming how many people are participating there. And I think that makes us the second largest Discord community in L1 chains. We've had up to 35,000 servers running our nodes or validators. We've had well over 300 events. I think that number needs to be updated because it's a month old and we've done a few more since then. And we've had a lot of people participating in launching dApps and interacting and transacting with each other. So the interest just at this point of testnet is incredibly high. We're very close now to going to our incentivized testnet, where you can participate and earn tokens, and we expect these numbers to go up quite a bit by then. Once we go through that process, we're ready to launch our mainnet. And once we are there, you can expect these numbers to explode. And again, participation is the goal for us. We want to go, everyone's welcome, and here comes everyone. Let's innovate together and make cool shit happen. In short, Sandipan, over to you.
So yeah, I'm going to share a little bit of resources on how and what are the things you can use to start learning about Shardeum and also start deploying dApps on Shardeum. And at the end, we are also going to see a basic demonstration of what you can actually use, like basic cryptographic principle, and build an end-to-end dApp, which is actually useful in the real world. So we're going to look that also, and we are going to be deploying on the Shardeum test network. So it's going to be an exciting stage. Before that, just wanted to share a quick success on Shardeum so far on the dApps which have already found their success. Even though we are on testnet, even though revenues are not being generated on chain, like these dApps found a way to capture not only an audience target, but also success in their revenue. So Minter, a one-click node provider, which lets anyone run Shardeum nodes, no matter even if you have run any blockchain nodes, or even though running a Shardeum node is 100 times more simpler than running any other blockchain nodes. But still, Minter makes it even one step further on a one-click provider, which using which anyone can deploy a Shardeum node. And as many of the points Chris mentioned, Shardeum, unlike other blockchains, benefits from having more nodes because it has the ability to auto-scale. And one other application was .shm. It's going to be the native domain name service for Shardeum, so you can mint your name .shm, just like you can do it on Ethereum and other services. So they have also done pretty good so far in the testnet, even though we are on testnet stages. And we want to showcase your dApps, the dApps which are being built in this hackathon, onto this slide in the next hackathon. So I'm looking forward to that. Coming to the resources part, so this is one of my projects which I have built for all the hackathon people. Even though hackathons can range from 24 hours to even month long, one thing which we all can agree on is that getting started, if you are especially new to the space, can be cumbersome, and also figuring out what are the things and the puzzles to fill in. So Shardeum dApp boilerplate exactly targets that. It's an end-to-end, like smart contract, front end, all the libraries already installed. I'm not using any custom wallet integrations or those kind of stuff. All of those are natively built, so you can understand each principles of how a dApp works from end to end. And you can go to this link on github.com/Shardeum/Shardeum dApp boilerplate. I will also share this after after the session in the chat, so you can directly open it. But yeah, definitely check out this resource. I'm going to do a much more in-depth review of this in the workshop, which is closer to the hackathon. So definitely look forward to that. And if you're not registered for that, definitely join that. We are going to dive deep into the dApp boilerplate repo. And another such initiative which we have taken is Shardeum University. It is also one of our, like, I would say, initiative in which focuses more on the communication of what are the things under the hood working, but also integrate other infrastructure providers with Shardeum. So this is also something which is we are working hard on. You can already go and learn 2 courses. One is about a very quick introduction to Web3, like it's a Web3 101 kind of course if you're entirely new to blockchain or Web3. And the other one gives you a little bit more insight about Shardeum itself, of what are the things, what are the current challenges, how Shardeum aims to solve those. And many such courses are going to come live in the next couple of months. The next course, which is already ready and will be live soon, is the deep dive for EVM. I'm sure many of you have worked with EVM before, but how under the hood it works, it's very interesting. Which is something Ethereum introduced. It has been so long, but still, I would say like finding a structured content of it is very difficult even this day. But yeah, we hope to solve that, and many such courses coming forward. Things to look forward to. Obviously, mainnet, we are currently on our testnet stages, on the final end of our testnet stages. We will soon launch our incentivized testnet, in which you can also participate by building dApps and all. But yeah, mainnet is something which we are gearing up for. And also grants program, obviously, like we will have a integrated grants program for all the developers and entrepreneurs out there. We are also going to bring Born to Build DAO. This is something which we are going to share more in the upcoming stages. So definitely keep a track of what's happening in the Shardeum ecosystem, and developers, content writers, like marketing, like anyone from any part of the like curriculum, like or section can join in. It's going to be very inclusive in that sense. But a lot of things are going to come from that Born to Build DAO also. And at the end, like accelerators and incubators, again, like for the people who are trying to build Web3 companies, they can hop onto the Shardeum network and they can start their initiative of running a company. It can start from a hackathon and it can turn into a company, and making that process smoother is like these accelerators and incubators are going to play a role in that. With that, like that's pretty much it. Like that's what I wanted to share quick resources on, but it's time to get started on a quick demo. Cool. So yeah, let's start with the dApp, which let's like before jumping to the dApp, let me just cover a few quick sections. Let's go to the Shardeum docs. So docs.shardeum.org. This is going to be the #1 resources for all of you guys. This is where you will get most of the information which you need, not only to learn more about Shardeum, but also on how you can start building your dApps, and also the key infrastructure features which you need in your dApps to configure while deploying. The most important part is, let's jump to the network setup tab. In this, you will see that currently there are 2 networks. One is the Shardeum Sphinx 1.x and one is the Shardeum Dev network. So as mentioned here specifically, this is especially built for you guys, the hackathon people and the developers. You can use this network. This network is going to be much more stable, will be much more reliable. And this network is going to have much more faster, quicker updates, but it may cause some issues here and there. So for development purposes, you can use this. Both are EVM networks, so anything which runs here will eventually run here also. But this is a developer-specific network for much more stability and all. So yeah, the RPC URL, again, Shardeum is an EVM-compatible blockchain. The only thing which you need to change in your dApps is the RPC URL, and you need to deploy your contracts on the Shardeum network. So the 3 most important links are the RPC URL, the block explorer, and the faucet. So I already have some tokens in my MetaMask account. Hopefully your MetaMask account also shows up. Yeah, so I already have some test tokens and I'm configured with the Shardeum dev network. If you're not, you need to do it for the first time using like adding the network manually. But yeah, that's pretty much it. Like that's on the network level endpoints. That's pretty much what you need to configure in your MetaMask and you're good to go. And let's now jump to the actual like dApp, which we are going to demonstrate here. So what I built is a Merkle tree dApp. So let's first understand what a Merkle tree actually is. And like this is a very basic computer science process, but which is related to the blockchain, may not even be related to the blockchain in some cases. But in this case, we are going to see how this concept is applicable and using which we can do an on-chain application, which has a real world use case and has been used in pretty big stuff. Like even though this is a very basic concept, you will be surprised in how big of an application this has been used in the past and is still going to be used in the future. So get started with the Merkle tree concept. So basically, a Merkle tree is basically it's sort of a tree, as you can like see. If you are from the computer science background, you must be like aware of trees and like binary tree and those kind of applications. But in this case, you have, for example, transaction A, transaction B, transaction C, transaction D. So these are individual data points. Like this data point can be anything. So these are individual data points. What happens is, like, at the first level, you just create a hash of this data. For example, for transaction A, we create hash A. Similarly, hash B, hash C, hash D. And then again, you join two of those hashes, and together you form hash AB. And again, you join two of these hashes, and you form hash CD at the end, while doing continuously. So this doesn't need to be just a scale. It can scale infinitively. Like it can be from here also two nodes can come up, from here also two nodes can come up. But for this example, we have 1, 2, 3 levels. And at the end, you get a top hash of ABCD, which is a combination of all the hash. Now, the very interesting part in this case is that just by using the top hash, you will be able to verify that whether transaction A is present over there, or transaction B is present over there, or the transaction C. So you don't need to traverse the whole thing. Just using this, you will be able to verify that. That's pretty cool. That's a pretty cool concept. But let's just quickly clone it, and let's just see why, like how it can be used actually. So let's just clone. And let me just also give you the link. So if you want to follow up, you can do so. Let me just drop the link in the chat. So open it and also do an npm install. So using just the concept of the Merkle tree, which we just saw, we are going to demonstrate on how this can be used in a real world dApp. And we will also have an on-chain part of it. So yeah, I think while the node modules are being installed. So yeah, this is a very basic Next.js application. You have the majority of your, like the important parts are in your pages, obviously, and also the scripts and also the utils. So this is configured with the hard hat network. Again, like if you are already a dApp developer, if you're already a DVM developer, you must be aware of all of these concepts. So I'm not going in depth into all of those. If not, it's still fine. You can start with this application, and like you can move forward from there. You can figure out one step at a time from there. But for demonstration purposes, I'm going to stick with the application on its functionality side. And again, like at the end of the session, I'm happy to answer any of those questions. So the majority of like what we just discussed of creating the Merkle tree root hash, and also to verify whether that particular hash is present in that Merkle tree or not, we are just using the Merkle tree JS library, and we are using the ethers library. Again, like the ethers library is something most of you are already familiar with. So yeah, we are just creating the hash address. We are just hashing. This is a like function which is just hashing the input with kachek256 function. And we have a function to create the Merkle tree. We have a function to get the Merkle tree proof. And we have a function to verify whether whether hash is present in that Merkle tree, and also to get the root hash. Now, again, like if it's getting a little bit confusing, it's fine. Once I demonstrate the main application with the front end, you will be able to much more visualize it. And so before that, I'm just giving a rough overview of what the application is. So this is the index.tsx file, the main file of our application. A single file. I've kept it very simple for all of you to figure out, like while you're going through this on your own time, to figure out what each of the moving parts are working. I'm also using RainbowKit. It's an awesome tool to like you can get started with connecting multiple networks, and it's configured very well. It's also UI UX wise pretty cool. So I'm also using Rainbow Kit for the Connect Wallet functionality. But yeah, if I need to give a rough overview of the code here, you will see that there is an allow list like variable here in which we are pasting the wallet addresses. So now is the time to visualize what is actually happened, and then again we are going to jump back to the code. Again we are going to jump into the code. So let's just go to the localhost. Now, all of you, I'm sure that all of you here must have heard about airdrops, like the basic concepts of rewarding your early stage users, right? So what happens in an airdrop? Like you reward your user with your token, but how do you make that functionality? How do you build an application in which you want to make sure that only the eligible people who have participated in a network before or have done any transactions or whatever your criteria is, only those people are able to claim your token? So that's basically what this application is doing, and that's basically what the Merkle, like the Merkle tree concept, which we just discussed, does. So as you can see, a pretty basic UI. We have the connect wallet. This is from the Rainbow Kit. Let's just connect our wallet. So let me just connect my primary address. So yeah, so I'm connected. Now what we'll do is like we'll generate a Merkle tree root hash and also a proof of this address. So once I generate, click on the generate button, you will see that a root hash is created. The root hash is exactly what we discussed, right? The stop hash. And we also have a proof. So what happens is that if the wallet address which you are looking for example, 0x24, if that wallet address is present in the allow list addresses, because this is the list on which makes a which gives us the ability to only allow those people who are in this allow list to mint the token. If that wallet address is present, only then you will get the proof generated. Otherwise there will be no proof generated, and this proof is generated by using the connected user's wallet address and also the proof or also the root hash of the user. So that's pretty much it. Like basically the functionality of Merkle tree and the root hash of all the what we just discussed so far. Now coming to the on-chain part, on where like what's the actual on-chain application of this. So as you can see, since my this 0x24 wallet address as seen in the like allow list addresses, this is an allowed address to mint the token. My root hash is also like my proof is also generated. You can see that the mint button, which was not previously available. Again, like if we just refresh the page, let's again generate the proof. The proof is again generated. The proof will be same. The root hash will be same if the data points hasn't changed. So now you can see that the mint button is available. Let's just click on the mint button, and the MetaMask pop-up should come up. As you can see, I'm configured with the Shardeum dev network. Let's just confirm the transaction. The transaction is pending. Let's wait for a while for it to get successful. And it's done. Let's just view the transaction on the block explorer. The transaction went through, and yeah, so the transaction is successful. Now coming to the part of what like the claim functionality is happening. As you can see, this is the address of the token which we just saw being minted on the airdrop builder website. Like this is basically the token, the claim your token functionality. And I'm importing the tokens. Okay, for some reason it's not showing up on the Explorer. There might be an RPC error, but let's just quickly refresh and see. Okay, yeah, there must be an RPC error, but hopefully if you rerun this application, it would work. Let me just again try to mint the token. So again, this is Shardeum is still in its testnet stage, so there might be an RPC error here and there, but yeah, these all will get resolved eventually. Let's just wait for another mint functionality. Cool. Let's just do one thing. Yeah, I think that will also be interesting to demonstrate. Let's just deploy the contract again right here and now. Yeah, so we have the .env.example file. Let's just rename it to .env. Now I need to get the private key. I'm going to use an account, which is hopefully, yeah. So I'm fine with you stealing testnet tokens from this account. So I'm going to use this account because you're all going to see the private key. So let's just use this private key. Again, this account has no real world tokens. So even if you want to, you won't be able to. But for this demonstration purpose, I'm showing it. And as you can see, our hard hat is already configured with one of the networks. So this is configured with BetaNet also. I think that is probably one of the reasons why it's happening. Where's the, yeah. Cool. So we are now connected with the hackathon network. Yeah. Let's just try deploying the smart contract now. Again, if you want to see like why I'm mentioning the smart contract, I'm not getting much in depth into the smart contract part because it's a standard ERC20 token. I'm sure by now most of you have already deployed tons of this. Like there's no change into it. I'm just using the my token. I'm just using in the constructor. I'm passing in the my token and MTK standard. It's the using the standard OpenZeppelin library, so no changes here and there. So yeah, that's the same simple token of an basic ERC20. So let's just do npx hard hat run scripts deploy.ts network is a network Shardeum. It's Shardeum. So hopefully the RPC won't give error this time. And if it doesn't, then you will also be able to see that once I add the token to my MetaMask wallet, it should pop up there also. But yeah, basically, as you can just see, like this is Shardeum is an entirely EVM compatible blockchain. I just made an RPC change and no change in my actual Solidity code. So now we have the new smart contract. Now what we can do is go to claim .ts file and we're going to paste that new smart contract. Then we are going to do a npm run dev, and hopefully this time it would work. So again, like this is the same wallet which we used for allow list. We are going to generate the proof that, okay, this wallet is actually eligible. Then we are going to click on the mint function. We're going to confirm. Oops. Yeah. Okay, the mint is successful. Let's just view it on the block explorer. Okay, yeah. So I think that was configured with the beta net, but it's fine. So now you can see that the ERC20 token is deployed. Let's just copy it, and if I import, yeah, now you can see that the 200 MTK tokens is now visible in the wallet address. So yeah, that's pretty much it. That a basic demonstration of an application. Like this is like you can consider this as an airdrop builder in which you allow list the wallet addresses. Again, creating the allow list can be done in a multiple ways. You can also have the like users sign, and using that the signature also you can create allow list. You can create a allow list just with the wallet addresses like I did. And this is basically the file which is handling all the proof and verification of the Merkle tree. So as you can see, like that's pretty much it, deploying an ERC20 token, just like any other EVM network, you can use that. And yeah, feel free to use this tool to build even further like dApps out of it. But also like you can also check out the dApp boilerplate. But yeah, I think that's pretty much what I wanted to demonstrate. Again, like all the resources I used here are found here. For testing purposes, only use this network for now. Again, as you can see, like I was using the past network, like it may not be stable at all point, but yeah, this network should work pretty good. So hopefully I'm all good. I can like open for some questions.
Yeah, I know that Chris has kind of been answering some questions throughout in the chat. I don't know if you want to go through and see if there's anything you want to add, or if you guys in the audience as well have any additional questions. Of course, feel free to pop them in the chat right now. Chris, was there anything you wanted to add, or?
I just wanted to express my appreciation for you when you run into errors. You can see that Sandipan is a true professional because he kept calm and he made it work. It's not easy when people are watching.
It's not.
Yeah.
And I saw that you said that in the chat as well. It's always when it's live, isn't it? That sort of stuff happens.
Definitely. Like it's not a workshop session if like one of the things doesn't break, but I think it's fine. Like everything worked out at the end. And I can also see a comment that Brew has so many accounts. Yes, I do. And if you need testnet SHM tokens, you can also reach out to me if the faucet is not working for you. But yeah, I do have a lot of accounts I use for testing.
And we spend a lot of time on our Discord. You can find it on our homepage. So if you ever need Sandipan or someone from our team to help, you can find us there.
Yeah, I wanted to kind of ask a general question for you guys, which might be interesting for people in the audience as well. What are you guys most excited to see being built during the hackathon? Like, if you were joining, what would you build? What's something you think would be like a cool avenue to explore?
Yeah, I think like Shardeum is an entirely new ecosystem, so we need dApps from throughout the categories. So like any of the like NFT side or the DeFi side, or even on the infra side, like any of those categories, like it's going to be pretty generic. So like anything you build will be new to the ecosystem and will be useful to the ecosystem. So go for it. Coming to the point of like applications, so if there has been some applications at which it other EVM networks, since there are like TPS capacity limits, like those run into issues. So I'm curious to see what those kind of applications can do. And again, like if you Shardeum is a sharded network, but smart contract interactions is still processed linearly in a case that it needs to be processed one by one. So what happens when there's a popular smart contract and a lot of transactions are happening? So build an application which tests the limit of Shardeum in terms of TPS. So some kinds of limit, like some dApps like that will be very interesting to see.
One of the things that I find interesting is that because of previous limitations, there were a number of use cases that just weren't interesting before. Now that you pay less than a cent per transaction and it's fast and scalable, you could build a place where you can buy domain names over Web3. Because checking a domain name is going to cost you a cent, and then transacting to purchase it is the same. So suddenly you can start building services on the internet through a Web3 interface and Web3 contracts, where previously that just wasn't possible before. So I think that the most exciting thing is, like Sandipan said, there were things that weren't possible before, even if you wanted to build a Pokemon Go where you have to go out in the real world and capture things in Times Square, New York. That would have not been possible just because the constraints of the networks would not allow that level of participation and interaction. And now you can. So the challenge, I think, is look at what you thought of before of what would be cool, but you dismissed it because it was not practical, and revisit that.
Cool. Okay. I'm sure that was hopefully that gave some people inspiration as well, some people listening. I saw that Prince actually asked a question in the chat. Is there a mechanism to revoke access for addresses in the whitelist?
It can definitely be done. Like you can just create a function in which revokes the access or removes it from the initial list. So it can definitely be done. So this is an open repository. So Prince, if you want to build that functionality into this, I will happily accept your PR. So definitely you can build it out. So yeah, definitely if you can build that out and you can raise a PR, other people can access that too.
I saw a question in the questions tab from Fahu. I hope I pronounced that correctly. What is the TPS we can expect in mainnet? The good news is that we have no idea, but we know that we can go as high as we need to. Just because the economic model of Shardeum is so that if the demand goes up, the amount of rewards that are given out to participating validators goes up as well. So it becomes economically interesting to run your own validator as well. So that pool will grow as the usage goes as well. And as we see more TPS, we will set more of those standing by nodes into active nodes. So again, the scale, we don't know. It could be hundreds, it could be thousands, it could be tens of thousands. We'll see how many transactions are happening. But it's definitely built to provide a framework and infrastructure that allows this kind of real world usage. So if you are building the next Pokemon Go in your own version of it and you get 1 million users, you will still be able to use Shardeum for it. And I think that's the potential here.
Yeah, I think, oh, another question coming in now. Could we use the domain name to replace Web2 domain to connect to a website? Damon wants to know.
Absolutely, you can. It has already been done before, like some other projects, but you can definitely do that. Also, you can just host entire websites on IPFS nowadays. So, that's absolutely possible.
Cool. And I see that people are typing, so I kind of want to give some more time for people to ask their questions, and keep the kind of chat alive. Is Shardeum recruiting for positions? Someone wants to know. Someone's very interested.
We are actually. I know we have openings for software engineers. There are 2 other job titles. I forgot what they are though. Do you know, Sandipan? I'm putting you on the spot here.
I will drop the link to our careers
Perfect.
page right now. I'm just doing that. Yeah.
Oh. And that's a good comment on the RPC server, the rate limits for it. So we have a rate limit per IP address, which is 5,000 requests per 5 minutes. We can change it over time. What we have seen is that large successful dApps as well as exchanges run their own JSON RPC servers. As soon as we launch our incentivized testnet, we're launching the open source versions of all of that code as well. So you'll just be able to deploy that on your own server and bypass any rate limits that exist. Gives you a guarantee of latency response time on your local network as well. So if you ever get to the position where you have the amazing problem of having way too many requests that you want to do, running your own JSON RPC server is a fantastic solution. I always love things in the good problem to have category. Oh no, I have 10 million users. What am I going to do?
For sure, for sure. And yeah, for those of you guys who missed it, who are just kind of listening, Sandipan just dropped the careers or job board link as well in the chat if you want to check it out. Okay, some more questions now. So can we expect more dApps when we reach incentive testnet?
For sure. Like lots of dApps. You can build one of the dApps to deploy on incentivized testnet. So yeah, definitely.
Yeah, we have a long list of partners we're collaborating with. So once ITN launches, they will be published and you can use those, definitely.
And are there any mechanisms in place to protect against front-running attacks during token claiming?
So the interesting part here is like, thanks for asking this question. So this is something also which would like to share, that there's no front-running opportunities on Shardeum. So that mechanism is entirely not at all possible, because Shardeum, like the transactions and how Shardeum processes it is linear in the sense of it's timestamp based. There's no bribing gas fees to get your transaction in front of any other transaction. So since the network is able to auto scale, it doesn't need to restrict the users to just that block space. If there is more transactions coming in, the network will just improvise and get bigger. So there's no fight with gas fees and gas prices. So there's no front running. So you can also be ensured that if you're placing a transaction in a correct order with nonce and correct nonce and those kind of things, your transaction will definitely get processed. So that's also one of the advantages of which the Shardeum tech and the dynamic state sharding brings.
That is also how we keep our transaction fees low. The network just scales up, so the transaction never becomes expensive. It's important.
And someone just asked a question that I actually know the answer to. And yes, there will be a recording of this session. It will be made available tomorrow already. And I will probably send that out at least to those who have registered to join the Scaling Web3 Hackathon. So if you haven't already, I suggest you do. And you'll get another workshop there from the Shardeum team as well. Is there any other questions? A nice reminder there for you as well.
Sure. For sure. That is my dev account. So yeah, if you want to mess that up, feel free to do that.
I see that someone is typing, so I'm just going to wait to see whether that's a final question. Otherwise, I think that might be it from us. Do you guys have any final kind of words, anything you want to finish off by saying?
I'm just really looking forward to see what people will build. Again, we are in Discord, so if you need any feedback, technical help, suggestions, brainstorming, hit us up there. We're here to help.
Cool. I actually saw now that someone asked whether there's any official tutorial on how to set up a Shardeum node, as well as some tutorial links. I don't know if you guys have any specific links you want to share before we finish up.
Yeah. Let me just drop a YouTube video.
Perfect. Thank you so much. And is there anything else you'd like to highlight about the Merkle Tree dApp or its underlying technology?
No, I think I shared all the main functionalities of it. Again, like as someone mentioned, like you can build out on top of it. You can submit PRs. Happy to accept those. And also, like, there's a lot of things that can be done. And as you saw, I'm not a great UI developer. It's pretty basic. If you want to improvise that, feel free to contribute over there also. So yeah, a lot of things can be done, but you definitely check that out. And also the dApp boilerplate. And once like we have the hackathon session, we'll dive more in depth into the dApp boilerplate also.
And Katya wants to know whether Shardeum Sphinx is a testnet. Sorry, I really struggled to pronounce that word.
It is. Shardeum Sphinx is the second iteration of Shardeum testnet after Shardeum Liberty. It is a testnet right now. Yeah.
Awesome. Okay. People just keep coming in with questions, so I keep kind of wrapping things up and then having to go back on my word. I'm going to give it another minute just to see whether there are any final questions. I see someone typing again. And are there any user feedback or community contributions that have influenced the development of the Merkle Tree dApp?
Like there have been, like, this is a very basic demonstration of a basic computer science like concept and how it can be used to build dApps. I just wanted to share both sides of the world so that like a basic concept and how you can apply into an EVM network and a concept. Again, like this, for example, this Merkle Tree dApp only does that for ERC20 tokens. You can build one whitelisting mechanism and also a minting mechanism for an NFTs, like so that people register for 24 hours, and then after 24 hours, the people who have registered only get to mint the NFT, and you can use that the Merkle tree concept and the libraries and how I showed like that function. It's a very small function. It's pretty easy to use with Merkle tree JS. You can also implement it manually if you want to have some more challenges on your path. But yeah, using a library is much clearer because someone has already built it for you. So using that is simpler. But yeah, definitely there's a lot of things that can be done.
Nice. Okay. I think what I'm going to do now is I am just going to kind of call it there. And then if you guys have any other questions, which I'm sure you will after looking into all these helpful links and stuff, feel free to join us for the next Shardeum workshop, where you'll be able to ask questions again. And I will, of course, keep you all updated on when that is. That will be part of the hackathon. Okay, that's it from me then. Thank you so much, everyone, for joining. Thank you, Chris. Thank you, Sandipan. And I'm going to let you guys finish off with some final words. And yeah, that's it.
Oh, thank you for organizing, Clara. You've been wonderful.
Thank you.
Thanks for hosting, and hashtag well done, Shardeum.
Hashtag well done, Shardeum. That's a perfect thing to finish off on. So see you all very soon, hopefully, and have a nice rest of your day.